uh, we have completed the portion of direct methods to find out the solution of system of linear equations. So now all these methods, they involve the Gauss elimination method, Cholesky method, and Gauss-Cholesky method. So in all these three methods, the procedure is well defined. Okay. So irrespective of whatever the values which are there in the matrix, whether it is -1, -4, whatever it may be, so you have to perform certain number of steps. Okay, like for example, Gauss elimination method, you have to eliminate, if it is a 3 by 3 matrix, you have to eliminate 1, 2, and 3 elements. Okay, so this is fixed.
So,
You cannot change this.
so,
So whether the matrix is having elements which are in multiples of thousands, or whether it is in
Sir,
multiples of 0.001,
sir,
the procedure is going to remain exactly same. Okay, so these method, that's why they called as a direct method, because the procedure is well defined. Okay, but there is another type of method which we call it as a iterative method. Now iterative method means what? We have a matrix, maybe it's a 3 by 3 matrix, or maybe it's a 4 by 4 matrix. So we have to choose certain solution. Okay, if it is a, let us say, 3 by 3 matrix, so I can choose the possible solution as 1, 1, 1. Let's say x1, x2, x3, these are the unknowns. So I will start with, let us say, 1, 1, and 1, and then I'll keep on improving the solution till I get the actual solution. Okay, so in this case, what happens, the number of iterations required, it is totally depending on the original matrix. So for example, if your actual solution
sir,
is 1, 2, and 1,
sir,
and you have
sir,
started with the assumption that my solution is 1, 1, and 1, so definitely you see the assumed value of the solution and the correct solution, they are almost very near. So in that case, the number of iterations which are required, they will be very, very less. So to solve a matrix of 3 by 3, you use direct method, you use iterative method. So both the time which is required to solve using this direct method and iterative method, they are completely different. Okay, so direct method, time is defined because step is defined. So irrespective of values, you have to do all those calculations. But in iterative methods, based on your assumption, your iterations, they are going to change. Okay, it can sometimes even increase, or it can even reduce. Okay, so we have one basic method that is called as Gauss Seidel method. Okay, shall I turn off the slide? Is it required? Okay, fine. So this is called as Gauss Seidel method, which we are going to see in today's class. Okay, so this is called as Gauss Seidel method. Okay, so this method, Gauss Seidel method, is very, very easy. Okay, because we have to just assume something and we have to go for the actual calculations. Okay, so for this purpose, I am going to take the problem which is exactly same as the previous one, which we have solved earlier. Okay, so I think in the previous class you have solved this. Okay, that is 10 times. I think if it is not visible, then let me copy and paste from this Cholesky 4 by 4. I think this problem which we have solved in the previous class, isn't it? So let me copy and paste this over here. Okay, so that my efforts are reduced. Okay, so now, so this is the problem which we have to solve. Okay, that is 10 minus 2 minus 1 minus 1 and so on. This is a symmetric problem. Okay, and we already know the solution of this problem, right? So now in the Gauss Seidel method, what exactly you have to do? So if you expand this, you are going to get 4 equations, isn't it? So let me write down these 4 equations for you. So this equation will be something like 10 times x0 minus 2 times x1 minus 1 times x2 minus 1 times x3 equals to, you have 3. बराबर है. Then you have another equation. If you expand the second equation, so this is minus 2 times x0 plus 10 times x1 minus 1 x2 minus 1 x3 equals to 15. Correspondingly, here you have minus 1 x0 minus 1 x1 plus 10 times x2 minus 2 times x3 equals to say 27.
So,
And lastly, minus 1 x0 minus 1 x1 minus 2 x2 plus 10 times x3 equals to minus 9. Is it so? Uh, Thank you. I don't know why, but I'm not able to hear them. So thank you for sharing this. Okay, so online students, I'm guessing that you can see my screen now. Okay, ठीक है, दिख रहा है.
Yes, sir.
Okay, so basically what I have done is, this was the problem, that is 10 minus 2 and so and so. So we have just expanded the problem, and accordingly we have just generated 4 equations. Okay, so now we have 4 equations, we have 4 unknowns. Definitely we can solve this. So ultimately we can go for any other method. So in the Gauss Seidel method, what exactly we have to do is we have to modify these 4 equations. Okay, so we have 4 equations, so I am going to use the equation number 1. Okay, so I am going to modify this equation, and I am calculating the value of x0 in terms of x1, x2 and x3. Okay, so here the x0 value will be something like 3. Okay, minus, so this will be plus, ये आ जाएगा 2 times x1 plus x2 plus x3 whole divided by 10. Is it okay? Right? Accordingly, now I am going to change this value or this equation, so that I can get the value of x1 in terms of other 3 unknowns. Okay, so here the expression will be something like this. So this is 15. Okay, so this will be minus की जगह आ जाएगा plus 2 times x0 plus x2 plus x3, okay, divided by 10. Okay, then we have, let us say, x2, right? So third equation I am going to modify for x2. So this will be 27 plus x0 plus x1 plus 2 times x3 divided by 10. All right, and here we have x4 equals to, this will be again minus 9, this will be plus x0 plus x1 plus 2 times x2 divided by 10, because the coefficients of x0, x1, x2 and x3 in all 4 equation is 10. Okay, so now we have 4 equations with us. x0 के लिए एक equation, x1, x2 and x3. I think I have written by mistake here x4. This should be x3. Okay, so now we have this. So using these 4 equations, now we can simply calculate the values of x0, x1, x2 and x3. Okay, so how to do this? Okay, so I'm going to use a simple table over here. Okay, so let me insert a table which says, let us say 1, 2, 3, 4 and 5. I'm going to insert a big table over here. Okay, so in the first I'm going to say iteration. Okay, here I'm going to write x0, here this will be x1, here this will be x2 and here this will be x3. Okay, so now here assumption. Okay, So like I said, in the Gauss Seidel method, we have to assume certain solution. Okay. So here I am going to assume the values of x1, x2, x3, all the values as 1. You can assume any value. You can assume either 0, 1, 2, 3, 4. Okay. You can assume 10, 10, 10, 10. It's up to you. Okay. It is totally depending on you. But depending on the assumptions, the solutions and number of iterations required, it will be more. Okay, so this is my assumption. So now let us go for iteration 1. Okay, so now in iteration 1 I'll be calculating first x0 value. Okay, so what is my x0 value? If you see the equation which is written at the top, we have the x0 equation which is over here. Okay, so let me use this expression. So if you use this expression, so x0 value is nothing but 3 plus 2 times x1 plus x2 plus x3 whole divided by 10. Okay, so here you have to use x1, x2, x3 value which are the assumed values. ओके, तो assumed value क्या है आपकी? x1 की 1 है, x2 की 1 है, x3 की भी 1 है. So if you substitute the x1, x2, x3 value in the first equation, so this is going to give you 3 minus 2 times 1, sorry, plus 2 times 1 plus 1 plus 1. तो ये कितना हो जाएगा? 5, 6, 7. 7 divided by 10. So this is the new value of x0. Okay, so this is 7 divided by 10. This comes out to be 0.7. Is it correct? Okay, so now why I'm getting this as 0.3? Okay, I have assumed 0, 0, 0. That's why. Fine. Anyway, so this is coming out to be 0.7. Then you have to use the second equation to get the value of x1. Okay. So now in this particular case, what exactly you have to do is you have to choose the assumed values. Okay. So here the x1 expression is 15 plus 2 times x0 plus x2 and x3. So now here x0 value you have to choose not the latest value. Okay, you have to use the assumed value, that is 1 value. Okay, so here also the एक second, let me check. I think we have to use the latest value. Yeah, we can take latest value, no issue. I am not able to recall it. Well, let us take the latest value. You will be getting the solution in the faster one. Okay, so 15 plus 2 times x0 plus x2 and x3. So x0 you have to take 0.7. Okay, x2 should be 1, x3 should be 1 divided by 10. How much is this x1 value? 1.84. Okay, so now similarly you use the another equation which is this expression. Okay, the third one to get the value of x2. कितना आ रहा है देखो? 3.15. And how about this one? Is it so?
Yes, sir.
Good. So this completes the first iteration, right? And if you see the actual solution, okay, I think we have the actual solution available with us because in the previous class we have solved this. So that is 1, 2, 3 and 0. Okay, so this was the actual solution. And if you see the value of this x0 is very close to 1. Okay, this is close to 2, this is slightly greater than 3, okay, and this is close to 0. And how many calculations you have done? Only one iteration, 4 calculation, that's it. So you see this method is quite easy. Okay, so now I want all of you to do the second iteration. Otherwise, in the other methods, you remember कितने सारे calculations करने पड़ते थे. You have to deal with all the matrices and all. Okay. So now you use the latest value of x0, x1, x2, and x3 to calculate the new values of x0, x1, x2, and x3. Yes, online students, are there any queries? I'm not able to hear you, so if you have any queries, please post it in the chat box. Okay. So very simple method, I suppose. But only thing is, it's an iterative thing. So in order to get this solution, you have to keep on doing iterations, iteration 1, iteration 2, iteration 3, and so on. Yes, anybody x0 value? 0.99819. गुड. प्लीज मेंटेन 4 डिजिट्स. हाँ, उससे तुम्हारे एक्यूरेसी भी आएगी और एक हाथ दूसरा इटरेशन भी बच जाएगा. ओके. यस, x1 एनीवन? 2.0098. Okay, everyone is getting similar values. Okay, anybody x2? 59. Okay, good. And how about this one? Minus 0.00. I'm putting 1.8. Okay. So you see, after the second iteration, you can find whatever roots you have getting after the second iteration, they are very close to the actual solution. Because we already know the solution. That's why I'm saying it is close to actual solution. But if you don't know the actual solution, you can see that if you talk about x1, so it was 1, then it was 0.7, then it was 0.9. So I don't know whether I have to stop at second iteration or not. Since I know the solution, that's why I'm saying this. Yes, we are getting a correct solution. But if you don't know the solution, then we have to go for more iterations. Okay, so you have to keep on doing iterations again and again, unless and until two consecutive values, all four values, they should come same. Okay, so we have to go for one more iteration after this. Okay, because we don't know the solution, isn't it? So do the iterations one more time and give me the values, please. 1.0015. Okay. 1.9998. 2.9998. Okay. 0.009. Good. Is everybody getting same? Yes. Iteration 3, same answers. Okay. So now if you look at this, so now I can say yes, the values of iteration 2 and the values of iteration 3, they are very close. So now I can say yes, yeah, this could be the solution. Okay, since we know, we can find out that iteration 2 is sufficient enough for me. Okay, but still, if you want more accurate results, so like the exact answer is something like 1, 2, 3, and 0. So what we are getting is 1.0015, which is not accurate. Okay, the second value is 1.9998, actual value is 2. Okay, so for this purpose you have to go for one more iteration if you want to have more accuracy. Okay, for the last one, that is for iteration 4, please do the iteration calculations please.
There is coming one.
Exact one.
Yes, 1.40.
Okay,
2 and 3.0001. The last one is 0.
exactly 0.
The 0.40.
ठीक है. So now again if you see the values of iteration 3 and iteration 4, still want accuracy, you over it. I'm sure after this iteration 5 will get 1 2 3 and 0. ठीक है. So you see this way is very simple. कोई इसमें याद रखने की जरूरत नहीं. नो नीड टू गो फॉर बिग मैट्रिक्स कैलकुलेशन. किसी का एल नहीं निकालना है, किसी का यू नहीं निकालना है, कुछ नहीं करना. नो मेथड ऑफ सब्स्टिट्यूशन, नथिंग. Okay, you just start with some guess values. Okay, and then you will end up with the correct solution, possibly maybe in 2 iterations, maybe in 10 iterations, maybe even 100 iterations. Okay, it totally depends on what values you are assuming. Okay, so if you see this, I have solved this particular problem using 0000 assumptions. Okay, all the values with 00 assumption, but to get the correct answer I required almost 7 to 8 iterations. Okay, but here in just 5 iterations we could get the correct solution. Okay, so like I said, this is the great difference between the direct method and iterative methods. Okay, so direct methods, it has the standard format, standard process. आपको पहले ये करना है, फिर ये करना है, फिर ये करना है. So your number of calculations are fixed. Okay, so for maybe a 4 by 4 matrix you may require half an hour to solve a problem using maybe Gauss elimination method. But if you use this, if you solve the same problem using iterative method, hardly 2 or 3 iterations you will get the correct solution. Okay, so this is totally depending on the data which is there in the matrix plus the value which you are assuming. Okay, so in this problem, if you I have assumed 1 1 1 1, अगर मैंने 1 1 2 2 एज्यूम किया होता तो हो सकता है 5 की जगह 2 इटरेशन लगे होते. Okay, so it totally depends on you. So in your exam, if someone is using, like she is using some different values, you are using some different values, both will end up with the correct solution, but the number of iterations she will require and you will require, they will be completely different. Okay, so it is totally depending on your assumption. So here, if your assumption is close to the actual solution, yes, you will get quickly. If it is far away from the actual solution, you will have to go for more efforts. Yes.
So there is no way by seeing the question that we'll be able to.
No. It's a pure guess. Okay. It's a 100% pure guess. Okay. And most of the softwares, like you have STAD or maybe FEM based softwares, they are using only iterative methods. So if you see the help or the manual of any of these structural engineering softwares, and if you search for solver, this is called as a solver. So you will find most of the solvers, they are based on the iterative method, not on the direct method. Because you see, for example, if you are doing a analysis for a, say, ब्रिज और मे बी अ गर्डर, ओके, और गर्डर के ऊपर से आपका एक ये जा रहा है, व्हीकल जा रहा है, ओके, एंड इफ दैट गर्डर इज डिवाइडेड इनटू 4 parts, so you need to find out the displacement at 4 different locations, for example. Okay, just hypothetical example. So if you're let us say you have a beam, for example, you have a 4 meter beam and you are measuring the displacement at every 1 meter. So initially the wheel is there on the first uh, at 1 meter, okay, that is the first point. So you will get deformation at first point, you will get deformation at second point. So at first point deformation will be higher, second point it will be lower, third point it will be lower, and fourth point it will be lower. Okay, so you can use any method to solve this. Okay, like you can use Gauss elimination method or even Gauss Seidel method. So you have x0, x1, x2, and x3. Okay, but when you know x0, x1, and x2 and x3 with you, so you keep it aside, and then you solve it for the second load position, which is there. The in the second set, the load is there on the second point. Okay, so when the load is there at the second point, so you have to solve the matrix once again. So for this purpose, if you use the Gauss Seidel method, and if you use the guess value, which is the solution of the first iteration, getting my point? So if you use the guess value as the solution of the first iteration, definitely you will be getting the results more quickly. क्योंकि यहाँ पर अगर 1 mm का डिफॉर्मेशन था, तो अभी वो जाके 0.8 हो जाएगा, और जहाँ पर लोड अभी है वहाँ पर पहले लोड नहीं था, तो दैट टाइम डिफॉर्मेशन वाज प्रोबेबली 0.5, अभी वो बढ़ जाएगा. बट इफ यू चूज दैट वैल्यू एज अ गेस, सो इसको सॉल्व करना ज़्यादा ईजी हो जाएगा. First time it will be hectic, okay, but for the second iteration it will be easy. Third iteration you can use the solution of the previous one. For fourth iteration you can use the solution of the previous one. So for this purpose, especially in the dynamics problem, so where we have a building is vibrating, तो आपके जो points हैं वो एक बार इधर एक बार इधर, so they won't be moving that rapidly. Getting it? So if you solved it for the first time, and if you are using it, if you are solving it for time is equal to 1 second, time is equal to 2 seconds, 3 seconds, 4 seconds, like that. So using Gauss Seidel method, it becomes very easy. Okay, your calculations becomes very easy. Okay, that's why most of the structural related softwares, they use the iterative methods. Okay, I'm not saying Gauss Seidel method. There are much more advanced iterative methods which are there, which are developed and which are being used in these structural analysis softwares. Okay, so this is the basic difference of the direct method and the iterative method. Okay, so I hope this is clear to everybody. So we will stop now. Let me take your attendance quickly. Okay.